This lesson is on solving literal equations. Now, solving a literal equation is basically the process of solving a formula for a given variable. You've been doing this already when you solve for x, but in these cases, there's usually multiple variables. You don't get a single answer such as x equals 5. Your answer may look like x equals y plus a minus 2, where there's multiple variables involved, and your answer is actually an equation or an expression for what that one variable equals. So the best way to start learning about this is just to get into one and solve a problem. This is an example of a literal equation. It's pretty simple. It's just a one-step equation. It's u equals negative 2x, and we're going to solve for x. This is just telling you which variable you want to isolate. So that means you're going to isolate x. You're going to get x by itself, like we're used to doing. It's usually x that we get by itself, but in these literal equations, it could be any letter. So to explain what we're doing here, I'm going to compare this equation with an equation that you're probably more used to solving, like 3 equals negative 2x. If you were going to be solving for x, you would need to get rid of this negative 2 by dividing, since dividing is the opposite of multiplication, and we'll divide both sides by negative 2. And you would say your answer is 3 over negative 2, or negative 3 halves. In this case, we're not going to get a single answer like that, but we're going to do the exact same process. We need x by itself, so to do that, we have to divide both sides by negative 2. These negative 2's cancel out, and I'm left with x by itself on the right side. And on the left side, I have u over negative 2. Now, it doesn't matter if you put your negative on the bottom or the top, as long as you have a negative there. And that's your answer. So you're going to be leaving your answers like this with variables. You're just isolating the variable that they're asking you to isolate. So your answer is x equals u over negative 2. Okay, let's move on to another problem. Now this one's a two-step equation, and you've solved two-step equations like this before when you've solved for x. So again, I'm going to compare it one more time with a problem that you're probably more used to seeing. So when you had problems like this, they're in the same format. We're still isolating x. This is the equation we're working with. This is just telling us to isolate x. But we're working with the equation 3x plus m equals negative 4, and our job is to isolate x. So it's very similar in format to this, an equation that you're probably more familiar with. If we're going to isolate x here, the first step we would do is subtract 2 from both sides. And you would get negative 3x equals 6. In this case, we don't have a number there. We have this m, but we're still going to do the same process. To get x by itself, we need to get rid of m. So we're going to subtract m from both sides. They'll cancel out here. I'll have negative 3x. The only difference is, on the right side over here, I could actually subtract 8 minus 2 and get 6. I can't subtract negative 4 minus m on this side, so I have to just leave it negative 4 minus m written like that. Since they're not like terms, I can't actually subtract them together. And then the last step you would do over here is divide both sides by negative 3, and you would get x equals negative 2 as an answer. In this case, we're going to do the same process. We're going to divide both sides by negative 3. Now we have to divide the whole side, so draw your line over the whole right side of the equation. Divide it by negative 3. The 3's cancel over here, and your answer on the right side just looks like that. So instead of getting a numeric answer like we did over on the right side, your answer is going to contain variables and numbers. It's going to be an actual expression for what x equals. So that's what literal equations are all about. We're going to do 2 or 3 more examples here. Okay, so again, we're solving for x to keep it consistent. Pay really close attention to what that is. It's not always the x that you're trying to isolate, and it makes a difference. All right, I'm not going to compare this on the side. We're just going to go ahead and solve it. Our job is to isolate x. That means we need to get rid of this. We need to get rid of the whole term. This looks a little different. Normally when we had a 3k, we would divide by 3. But we're not doing that because we're treating this whole term like it's a 5. Just like if you had 4x plus 5 equals 4. And I know I said I wasn't going to show you another example on the side, but so you're treating this right here like it's a 5. And it's being added, so we have to subtract it, the whole thing. Not just the 3. We're not dividing it, we're subtracting it because it's being added. So that the whole 3k gets canceled on the left side. And on the right side, we can't subtract them because they're not like terms. We just write 4 minus 3k. And then the last step is like before. We divide both sides by 4 because the 4 is being multiplied and I want to get rid of it. Divide the whole right side by 4. And your answer is x equals 4 minus 3k over 4. Just like that. Okay, and I think we have 2 more examples. Some are a little shorter. This is a pretty short one. Alright, so in case that's a little blurry for you, I'm going to rewrite that equation. It's z equals m minus a. This time we're isolating a. It's telling us to solve for a. That means we need to get a by itself. In order to get a by itself, I need to get rid of this m. Now the m is positive. It's not being subtracted. We don't look at what's after it. It's a positive m, so to get rid of it, I subtract m from both sides. And I have z minus m. You have to have the minus sign in front of the m if you're subtracting it. It has to be z minus m. The order is very important with subtraction. And then on the right side, the m's have canceled, and what's left is a negative a. Because it had a minus sign in front of it, it's a negative a. I can't leave my answer like this. I need to know what a equals, not what negative a equals. So to fix that, I can divide everything by negative 1. But I don't want to actually leave it as negative 1. You could also think of it as multiplying everything by negative 1. Might be an easier way for you to look at it. Because what's going to happen is you're going to change the signs of everything on both sides. So when we multiply by a negative on the right side, negative a times negative 1 becomes positive a. As long as you're distributing and you're multiplying or dividing every single thing by a negative 1, you're in good shape. The z is going to be negative, and the m is going to be positive when you multiply them both by negative 1. And that's your answer for that one. Okay, one last example. This is u equals x times y times z, and we're going to solve for x. This is a simple one step. We can divide. We know we're going to have to divide because we're going to have to get rid of the y and the z in order to get x by itself. And since both y and z are being multiplied by x, we can do this all in one step. We can divide the whole thing by y and z at the same time. And that will cancel out the y's and the z's all at once. And what I do on the right side, I have to do on the left side. So my y's and z's are canceled on the right side. My answer is u over y times z equals x. It doesn't matter how many letters you had with that x. If they're all multiplied by x, you can divide them all at the same time like that. So that's some of the more basic literal equations. They do get a lot more complicated, but these are some of the 1 and 2, 3-step types of equations for solving for a particular variable.